And so I think everybody was here yesterday. If you weren't, this is what we played around with. We had this this virtual momentum lab, and it was so. As it turns out, the specific quantities I gave you aren't really important. In fact, I'm not gonna change these quantities. This isn't what I asked you to do, but it's fine. It's gonna work. And so what I want to show you is a way that you can, from now, keep track of stuff. Okay, so the first thing is what I always recommend with momentum, to the best of your ability, use a spreadsheet. So much easier. So I'm going to take all of this information and I'm going to copy it and paste it into a Google Sheets document. And so this is going to make my life a lot easier in some ways, because now I can just type numbers and I can kind of keep track of things. I'm going to delete these because I'm not actually going to use those masses. I'm going to use whatever shows up here. So so we know the mass of ball number 1 in this activity was supposed to be 1 kilogram the whole time. And the velocity of ball number 1 was supposed to be 1 meter per second the whole time. So I'm gonna add some stuff to my spreadsheet. I'm gonna add a column that is the mass of ball number 1. And that's gonna be 1 kilogram every single time. And I'm gonna add a column that is the velocity of ball number 1 before the collision. And that, if you look at the assignment, is supposed to be 1 meter per second every single time. So I can just put 1 in here. And units, unfortunately, when you're dealing with Sheets or Excel, we want to leave units off, okay? And then I'm going to add another column, and that's going to be my velocity of ball number 2 before the collision. So now you can see what's going on. I've got 2 objects, which means I have 2 masses, and each object has 2 velocities, 1 before, 1 after. 1 before, 1 after. It gets really tricky keeping track of this stuff. The spreadsheet will help, so that's why I'm encouraging you to put this on a spreadsheet. We also, ultimately, are going to need to have some variables that we can use to keep track of this stuff better. That's where the little prime and all the terminology is going to come in. But we don't have to worry about that for today. The velocity of ball number 2 before the collision is supposed to be negative 0.75 meters per second every time. So I'm going to just put that in, negative 0.75, and I'm going to have that just be my velocity every time, all right? And then the mass of ball number 2 changes. In the assignment, what I asked you to do is have it be 0.7, and then 1, and then 1.4. So actually, I'm going to change my mind here. I am going to change it. I'm going to make this mass, I'm going to make the mass of ball number 1, 1 kilogram. The mass of ball number 2, 0.7 kilograms. We'll just do this first one. The initial velocity of ball number 1 is already 1 meter per second. Ball number 2 is going to be negative 0.75 meters per second. Okay? And then when I hit go, they're going to bonk into each other. And then after the collision, the velocity of ball 1 is negative 0.44. So I'm going to put that into my spreadsheet. Negative 0.44. That was with a mass of 0.7 for my second ball. And the velocity of ball number 2 is 1.31. So I'll put that in to my spreadsheet as well. Okay. So 1.31. All right. And then one of the things that you can, so there's a couple different ways you can do this. You can play around with Google Sheets so that so that you can make these columns smaller, and you can adjust the column headers so that they wrap a little bit differently. And now we can like see a little bit more here, right? So this is weird, it's not pretty, but it gets the point across. We've got mass of ball 1, mass of ball 2, velocity of ball 1 before, velocity of ball 1 after, velocity of ball 2 before, velocity of ball 2 after. What I'm gonna ask you all to do today is do some basic calculations with momentum. So the assignment that's posted to Canvas is called Virtual Collisions Lab Analysis. And what we're looking for is the momentum of each ball before and then after the collision. So if I go back to my spreadsheet, that's pretty easy to calculate. Now, I can just calculate P of ball 1 before, P of ball 2 before, P of ball 1 after, and P of ball 2 after. And you can write the word momentum there, that's fine. Momentum is mass times velocity. Some of these things I can do in my head because there's some ones involved. Some of them I'm going to need a calculator for. The momentum of ball 1 before the collision is 1 times 1. It has a momentum of 1 kilogram meter per second. The momentum of ball 2 is going to be its mass times its velocity, and I can't do that in my head. 0.7 times 0.75, it's going to be negative 0.525. The momentum of ball 1 after the collision is going to be its mass times its velocity. The negatives matter, so this is negative 0.44. And the momentum of ball 2 after the collision, I can't do that math in my head, it's 0.7 times 0.31, so that's 0.917. The units here would be kilograms for the masses, meters per second for the velocities. So these momentums should be in kilogram meters per second, okay? And then, and I'm gonna make these smaller too. I'm gonna make my words wrap. And then the last calculation that's going to show up on this table is the total momentum before and after the collision. And again, the spreadsheet is going to make this much easier. The total momentum before, the total momentum after. So the total momentum before is going to be the momentum of ball 1 plus the momentum of ball 2. So that's 1 plus negative 525. So that's 0.475. The total momentum after is going to be negative 0.44 plus 0.917, or about 0.477. Those are pretty close, aren't they? And what you should see is that that's a relatively consistent pattern. And this is going to be the start of our exploration of transfer of momentum and conservation of momentum, which is going to lead us into next week. What I want you to do for today, the big goal of the calculations today, is just keeping track of all the numbers. And it's not a matter of, do you have it right? Do you have the right answers? It's a matter of, can you consistently keep track of the numbers, whether it's on paper or in a spreadsheet? Because otherwise what's going to happen is you're going to multiply the wrong things, you're going to add the wrong things, you're going to end up with the wrong information because it's a record-keeping nightmare. So what I just showed you very quickly is the product of literally years of practicing this stuff and figuring out, oh, if I don't write this, if I don't, spell everything out, if I don't put every piece of information into its own column in a spreadsheet, I'm sunk. You'll see next week how I do this by hand. Sometimes it's easier to keep track of these things by hand. So we'll do that next week. There's a relatively simple way to do that as well. But what you're probably gonna find is, if you try to approach it in a way that is not as methodical as this, you'll lose track of something. You're gonna forget which velocity was before or which was after, which was ball 1, which was ball 2. You're gonna get a mass and a velocity mixed up, you're gonna drop a negative, and what you'll end up with is calculations that don't reflect the actual data that we collected. Okay? So your job for today, for the rest of the period, is to work on and think about the virtual collisions lab analysis. For those of you who didn't get the data, I'm gonna finish this right now. And so if you got data yesterday, you can use yours. If you're not sure if yours is correct, then you can wait. I'll show you the correct data, so in 2 or 3 minutes, you'll have correct numbers for all the masses, all the velocities, and then if you weren't able to get the data, you can use mine to do the calculations, all right? Okay, if you have any questions, let me know. Otherwise, you can go ahead and get started on this.